Dear students, today we are going to discuss about the arithmetic progression, which is defined as a sequence or series is called arithmetic progression if the difference between a term and its preceding term is constant throughout the whole sequence or series, and the constant number is called common difference. For example, you can see that 2 plus 5 plus 8 plus 11 plus 14 plus 17 plus 20 plus ... is a series. Here 2 is first term, and this first term is always denoted by A, and 5 is preceding term. 5 is said to be the preceding term, and you can see between 2 and 5 there is difference of 3, and you can find that difference D is equal to second term minus first term. You can see here in this series, second term is 5 minus first term is 2, so 3. This 3 is called common difference, and it is constant term. Similarly, you can find the common difference from these two terms 5 and 8. Again, if you take this 5 and 8, then you should take 5 as first term and 8 as the second term. So 8 minus 5, again you will get the same number 3, which is constant. In this series, between two terms there is a difference of 3. So this 3 is said to be common difference. So it is shown here. Common difference has the formula. Common difference D is equal to second term minus first term. So like this you can find out the common difference. Similarly, we have another example. 9 over 7 plus 5 over 7 plus 1 over 7 plus ... Here you can find the common difference by the formula. Common difference D is equal to second term minus first term. Here second term is 5 over 7 and the first term is 9 over 7. Second term 5 over 7 minus 9 over 7. In the denominator you can see 7 and 7. So we can write 7 as common. And if we simplify, we will get 5 minus 9. It will give minus 4 over 7, which is common difference, and it is denoted by D. Similarly, you also can find out the common difference between these two terms, 5 over 7 plus 1 over 7. Here we can find D is equal to 1 over 7 minus 5 over 7. Now you can see 7 is the common, or we can say it is LCM. If we simplify, we will get 1 over 5. It gives minus 4 over 7. Okay, so this one and this the common difference, and the common difference is always constant throughout the whole sequence or series. Similarly, you can find the common difference for another sequence, which is given as A minus D, comma A plus D, comma A plus 2D, comma ... Here A minus D is the first term, and we always denote the first term by A. And we have the formula common difference D is equal to second term minus first term. Second term is A. Second term is A, so we write A minus according to the formula. So, and in the first term we have A minus D, so we should write A minus D inside the small bracket. So A minus times minus, it will give plus. So A minus and A plus, these two terms will cancel out, and remaining term D is called common difference. Like this way we can find out the common difference from the given sequence or series. Dear students, now we discuss about the general term of an arithmetic progression. For this, we should consider first term as A. Let A is the first term and D is the common difference of an arithmetic progression. Then first term is always denoted by T1. T1 is equal to A. Here you can see T1 is equal to A. This A again can be written as A plus 1 minus 1 D. This can be, because if you solve, you will get A plus 1 minus 1 is 0 D. It will give, ultimately it will give A. So this one A and this one A same. So T1 is equal to A can be written like this. Similarly, for the second term, we denote the second term as T2. T2 is equal to A plus D. Since D is the common difference, so in each step or in each coming terms, we will go on adding D plus like this. Here, in the first term, we have added only 1D, so A plus D. In coming next term, we have again added D plus. That is here, this A plus 2D can be written as A plus D plus D. So A plus 2D. As D is the common difference, we add plus D in each coming term. And T2 is equal to A plus D can be written as A plus 2 minus 1 D. 2 minus 1 D. Why do we write 2 minus 1? It's because since here is 1, so we have written 1 minus 1, but here is 2, T2, so we write 2 minus 1. And if we operate, we will get A plus D. Similarly, T3 can be written as A plus 2D is equal to A plus 3 1 minus D. You can see now nth term, which is also called the general term, can be written as Tn. First term can be written as T1, second term T2, third term T3, and similarly nth term can be written as Tn is equal to A plus n minus 1 D. Since in third term we have written here T3, so we have written 3 minus 1. Second term T2 can be written as 2 minus 1. T1 can be written as 1 minus 1. Similarly, nth term can be written as n minus 1. And this Tn is equal to A plus n minus 1 times D is called general term. Like this way we can find out the general term, and this is one of the very important formula for this arithmetic progression. Dear students, now we are going to solve few examples related to the arithmetic progression. First example is, if the first three terms of an arithmetic sequence are 16, 22, 28, then find common difference, general term, and next three terms. Okay, you can see the solution as the given sequence is 16, 22, 28. We have the given sequence this, so we write like this first of all. Then for the common difference, D is equal to second term minus first term. It is the formula to find out the common difference. So here you can see 16 is the first term, 16 is first term, and 22 is the second term. So in place of second term, you can write here 22 minus 16, you will get 6. 6 is the common difference and it is denoted by D. And the general term can be obtained by the formula Tn is equal to A plus n minus 1 D. This is the formula to derive the general term. So in place of A, you can write 16 as it is the first term plus n minus 1. In place of D, you can write 6 because we have just obtained D by the formula of the common difference. So you can see 16 is same, and n minus 1 times n minus 1 times 6 can be written as 6 times n is 6n minus 6 ones are 6. If you operate, you will get Tn is equal to 6n plus 10, which is the general term. Dear students, now we are going to derive the next three terms. As you have already seen in the sequence, 16, 22 and 28 are the first, second and third terms, and now we are going to discuss about the next three terms. After third term, we will get fourth term. So to obtain the fourth term, again we use the general term of the sequence, that is Tn is equal to A plus n minus 1 D. Here, as we are going to find out the fourth term, so in place of n we write 4, that is T4 is equal to, in place of A we have written 16 plus, in place of n we write 4 minus 1 because we are going to find out the fourth term. So 16 plus 4 minus 1 is 3 times 6. If we operate, you will get 34. It is T4. That means fourth term. Similarly, dear students, you can find out fifth term. So for the fifth term, we have the formula Tn is equal to a plus n minus 1 times d. In place of a, you can write 16 plus, as you are going to find out the fifth term, so in place of Tn, you can write here T5. So in place of n, you also can write here 5 minus 1, as common difference is 6. So 16 plus 5 minus 1 is 4 times 6. So 16 plus 6 4s are 24. 6 plus 4 10. So it is 40. That is fifth term is 40. Like this, you can find another term also. Dear students, now we are going to solve next question, which is a long question, and it's very important. So you should watch carefully. There are 60 terms in a finite arithmetic progression. If the first and the last terms are 8 and 185 respectively, then we have to find out the term number 32. 32th term, let us say. Solution is given like this. First term, according to question, first term is 8 and the last term is 185, and total terms are 60. So I have written n is equal to 60. Now 32 term is equal to what? We have to find out that. In order to find out the 32 term, again we use the formula, which is the general term. Okay, and general term is Tn is equal to a plus n minus 1 times d. Tn is the last term. Last term is denoted by Tn. In place of Tn, you can write 185. So here we replace Tn by 185 is equal to, in place of a, you can write a as it is the first term, and total number of terms is 60. So in place of n, we write 60 and minus 1 times d. Then 185 is equal to 8 plus d. This 60 can be multiplied with d. 60 times d, 60d minus d1 d. If you operate, you will get 185 minus d is equal to 60 minus d. On solving, you will get d is equal to 3, which is the common difference. As we are going to find out the 32th term, so T32 is equal to a plus, here was n. So in place of n, you write here 32 minus 1 times d. Then in place of a, you write 8 because it is the first term, plus 32 minus 1, 31 times d. 8 plus 31, in place of d, you have written 3. So this 3 can be written in place of d here also. So on solving, you will get 101. This is the 32, term number 32. So term number 32 is 101. Term number 32, here you can see. So term number 32, 101 is our required answer.